Let's talk about how the output impedance of one stage can interact with the input impedance of the next stage and mess you up. So what I'm going to do is I'm going to make a sensor here, and I'm going to give us 10K of output impedance, and I'm going to drop our capacitance down some so it doesn't come into play. I'm going to drop an amplifier stage, and I'm going to ask for a gain of 10. And we can see we're getting our nice 20 dB, I guess 20.1 because we're using E96 value resistors so that you can actually buy them, but very close to the gain of 10 that we want. Now what I'm going to do is I'm going to ask for minus 10, and you can see we're not getting anything close to what we want here. And as I increase my resistors, we get closer and closer to that 20 dB that we're expecting. And that's coming from the fact that I have this 10K output impedance, which is interacting with the input impedance of my stage. So let's go back to whatever, let's do like 1K, there we go. And I can actually go look at my input impedance of my stage. We can see we have this 1K here. It'll start to do kind of funny things when the bandwidth of the amplifier starts to roll off. So we got this kind of weird behavior here, but in the area where the amplifier is working normally, we get exactly what we expect, where the input impedance of this inverting configuration equals R1. You can see as I move the resistor values, I keep my input impedance always to be the same as R1. Another area where we can see, so back here's our gain, we're still not at 20. Another area we can see is if we go to the DC error, you're going to see your nominal gain here, and as I change it, you can see how the nominal gain changes there. And there's this little warning that tells you, hey, look, your gain is different than you requested, and it's going to break down what are the contributors, and we can see that the main contributor here is the source impedance of that amplifier stage. That's another one. So that's a problem for inverting configurations. Another type of configuration is when we're trying to do gains less than 1. Another type of configuration where that's a concern is differential amplifiers. So differential amplifiers also have the same kind of input impedance. So if you need a first stage and you don't need that, worry about the input impedance stuff, then do an op amp or an in amp. That's a gain higher than a gain of 1. Okay, so that's how input impedances and output impedances interact in the tool.